All right, guys, so this is weekly homework number 15. This is Tuesday because Monday was a holiday, so we do not have homework for that day. You're welcome. So number one says, what is the GCF of 35 and 45? Well, there's a couple different methods you guys can use to figure this out, right? Let me zoom in here. There we go. So we could do the tree method, which is what Miss Minix's class usually uses, which is this right here. When we split it in half, right? And we think what numbers can go in here? Well, we know 5 times 7 can go in there, and you keep breaking it down until you get to your prime numbers. Once they're prime, you circle them, right? And these two numbers are prime. Then you would do the same thing for 45. Find two numbers that go into that make 45, and keep breaking it down until you get to prime numbers. Then you're gonna figure out which ones are in both numbers and pull those out. All right, if you're using Miss Gonzales' method, which is the method actually I prefer, don't tell Miss Minix I said that. She might get mad. You would do the cake method. So you put two numbers like this and think what numbers can go into both of these. Well, I can divide by 5, right? So if I divide by 5 both these numbers, I'll have 7 here and 9 here. And then if you can, you're going to keep going down and multiply more. But if there's a number that doesn't go into both these, then you're done and you'll have your GCF. All right, that is the methods of doing these for number 1. Number 2 says write an algebraic expression 30 more than the quotient of B and C. Well, let's look at what quotient means. That means division, doesn't it? So all you're doing is writing an expression. You don't have to answer the question, but it says 30 more than, and this is one of those Yoda terms that I talked about in Miss Minix's class, the more than. So focus on that. We know quotient means division, so just write an expression that basically says what this is: 30 more than the quotient of B and C. Since it's more than, it's going to be plus 30 in there at one point, right? There's going to be a number in front of here. So good luck. I'll let you guys try that one on your own. Number 3 says Ryan has 5.5 pizzas. He split it equally between his 7 friends. What fraction of the original pizzas does each friend have? So he has 5.5, right? So I'm going to write that out. 5 and 1/2. One sec. We have 5.5 pizzas. He's going to split it equally between his 7 friends. Splitting it equally means that we're going to divide equally by how many? 7 friends, right? So then all you need to do is do 5.5 divided by 7. And if you guys remember, you're going to turn this into a fraction. How can I turn 7 into a fraction? All you got to do is put 7 over 1, right? Because whole numbers are always a fraction. It's just over 1. And then how do we divide fractions? Or you have to keep, change, flip. First you need to turn this mixed number into a improper fraction. And how we do that is 5 times 2. See if I can draw an arrow here for you guys. So we're going to go here, and that's going to be times. And then whatever you get for here, you're going to add here. So 5 times 2 is 10, plus the 1 equals 11, right? And you keep your denominator the same. So it's still going to be over 2. I'm going to bring this down right now. And we're not done. We have 11 over 2 divided by 7 over 1. Now you have to remember to keep, change, flip. KCF. Keep, change, flip. That's as much help as I'm going to give you guys. Hopefully you guys can figure this out. Number 4 is, what is the reciprocal of 3 over 7? I'm not going to do this one for you guys, but just think of what we just did on number 3. Keep, change, flip. When you flip, that's your reciprocal, right? So what would this look like if you flipped it? Hopefully you guys can get that one. It's a super fast one. Number 5 says evaluate the expression. So value is your key right there, which means we need to find the answer to, right? So what are we going to do first? You got to think of Pemdas, which means parentheses, exponents, multiplication or division, whichever comes first, adding or subtracting, whichever one comes first. So let's ask, do we have parentheses? Do we have a parentheses? We do, right? Right here. So that's what the first part I'm going to do is my parentheses. So I'm going to underline it because that's what I'm working on. So inside the parentheses, there's 8 plus 2 minus 3. Well, which one comes first? Either adding or subtracting, whichever shows up first, left to right. So we have 8 plus 2, which equals 10, right? And then bring down your minus 3. We keep working on that out. 10 minus 3 equals 7. So that's what our parentheses ends up turning into. Right, that's what our parentheses turned into. The rest of your equation you can bring down. I'm cheating, I'm not writing it over like you guys have to. A little 2 is going to be right here. Okay, so that's what it turns into, right? Now we have to see, do I have any parentheses? No, I don't. So the next thing we're going to do is exponents, right? So let's see here, do I have any exponents? We do, we have a to the power of 2 right here. So what is 7? Is it times 2 or 7 times 7? Remember, exponents are always times itself. It's how many times you're times it by itself. So 7 times 7. If it was 7 to the third power, it would be 7 times 7 times 7, not 7 times 3. So this is 7 times 7, which equals 49. I hope nobody puts 14 right here. Right? And then we're going to bring down the rest of our equation, because that's the next part we just did, and keep working out. So we're done with exponents, right? Now we got to figure out, do I have multiplication or division? Looks like I do. So that's your next step. You guys can figure out the rest. Good luck. You know what? I figured I'd put Wednesday on here as well, while I can. So Jeannie got the following question on her homework. 3/4 to the third power. Her answer is 9/12, but after simplifying it, it became 3/4. Do you agree with her? Justify your answer. So if we have 3/4 to the third power, I know I need to rewrite this stuff real quick. Okay. This essentially means, well, when I have my parentheses like this, that all these are going to be multiplied by 3. So we would do 3 times 3 times 3 over 4 times 4 times 4. And what will we get? Would you get 9/12? Or would you get something else? What's 3 times 3 times 3? Well, we know 3 times 3 is 9. 9 times 3 is 27, right? 4 times 4 is 16. 16 times 4 is... I can't do that one in my head, so let's work it out. 14 times 4. Not 14. 16 times 4. See? Even us teachers make mistakes, guys. It's alright to make a mistake as long as you catch it. Because I was writing my steps out, I caught it. Okay, so 4 times 6 is 24. I'll bring my 2 up here. Now 4 times 1 is 4, plus the 2. So I got 64. So this is going to be over 64. That's what we get when we cube this. That's what to the power of 3 is. It's also known as being cubed. So her answer is 9/12, but after simplifying it became 3/4. Do you agree with her answer? Justify. Now you gotta explain. Well, no, not quite, right? It looks like she did 3 times 3, not 3 times 3 times 3. And she did 4 times 3, right? That's how she got 12. Not 4 times 4 times 4. So I think if you simplify this, one sec, let me see. So now I'm seeing if these can be simplified. Can 27 over 64 be simplified? I don't think it can, actually, because 2 can go into 64, but it can't go into 27 since it's odd. 3 cannot go into 64 because if you add 6 plus 4, that's 10. That's not a divisible of 3, or divisor of 3. 27 turns into 9, right? But that doesn't go in. So we don't have 2, we don't have 3, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 goes into this one but not this one, 9 goes into this one but not this one. So it doesn't look like we have numbers that go into both these numbers. 27 times 2 is 54, so that's not going to work either. Yeah, it looks like there isn't a number that goes into both these, so that is simplified. So are you going to agree with her? Yes or no? Alright, number 7 says simplify the expression. It doesn't say answer it, it just says simplify it, right? Oh, of course, we got a bell. So what we got to do is find our like terms. And on our like terms, we have 9p plus 3p plus 4 plus 9. So these are the same, right? And remember, when there isn't a subtraction or plus sign or minus sign up here, that means it's automatically a plus sign because it's already telling us it's positive. So we can combine these. 9p plus 3p. What's that? What's 9 plus 3? That's going to become 12p, right? And then can you combine 4 and 9? Absolutely, right? What's 4 plus 9? That is, I'll let you guys finish this one. Alright, so this one tells us that there's a square and the perimeter is, so what is the perimeter of a square with the side length of x plus 2? So one of our sides is x plus 2. If it's a square, well, we know all the sides are x plus 2, right? And if it's perimeter, all you have to do is add all your sides together. So all you're going to have to do is x plus 2 plus x plus 2. And you're going to do it 4 times, right? Actually, I'll just set it up for you guys right here. So this is what it's going to look like. Well, except that there should be plus signs in between these guys. I can grab a stick. Okay. So x plus 2 plus x plus 2 plus x plus 2 plus x plus 2. Then if you can simplify it, you have your answer. Remember, you can combine like terms. When a letter is x, like it says x without any number in front of it, we know there's an invisible 1 in front of it. It's the same as saying 1x or 1 times x. So that's what you guys can leave this as. Number 9 says evaluate the expression below when f equals 2. So we have 5f minus f squared. So if we know we're going to have our 5 here and fill in our f. What's our f? Well, we said it was 2. So we're going to say minus 2 squared. Make this guy smaller. Alright, and then you guys can solve for this. And last, we have number 10. Factor the expression 27m plus 18. So what we need to do is find our GCF, those two numbers. We have 18 and 27. I would do the cake method just like this to figure out what numbers can go into both of these. I know I can factor out a 3. 18 divided by 3 is 6. 27 divided by 3 is 9. Can I keep going? Yes, I can. So I'm going to keep going. I can factor out another 3. Oh. So this becomes 2. This becomes 3. And now these are prime, so I can't go any further. So then what I got to do next is just multiply these numbers that are on the left side. These guys right here that I'll circle. So 3 times 3 equals 9. So that's what I'm going to factor out. So 27 divided by 9 is 3. Plus 18 divided by 9 is whatever's left over here, which is, and that should be our answer, but it's actually 3m. Don't forget to add your variable back in there as well.